Adsorption. Let us now understand adsorption. The accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed as adsorption. Suppose we have oxygen gas in a container having charcoal. Initial pressure in the vessel be P0. Number of oxygen molecule above the surface of charcoal equals to N0. Pressure decreases to Pi and note that Pi is less than P0. And also number of oxygen molecule above the surface are Ni and Ni is less than N0. This happens because oxygen molecules get adsorbed on the charcoal surface. Here, oxygen is adsorbate and charcoal is adsorbent. Adsorbate. The molecular species or substance which concentrates or accumulates at the surface. Adsorbent. The material on the surface of which the adsorption takes place. Text. Note that adsorption is a surface phenomenon. And also, materials in finely divided state are good adsorbents. Desorption. Let us now understand desorption. Let there be silica gel on which water molecules are adsorbed. Let's keep the arrangement in vacuum. The water molecules, owing to pressure gradient, get desorbed from the surface of the silica gel. Text. Note that both adsorption and desorption occur due to concentration gradient across a boundary layer. Distinction between adsorption and absorption. Let us now understand distinction between adsorption and absorption. In adsorption, the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the absorbent. In absorption, the substance is uniformly distributed throughout the bulk of the solid. Let us take an example. When a chalk stick is dipped in ink for a small period of time, the surface retains the color of the ink due to adsorption of colored molecules. On breaking the chalk stick, it is found to be white from inside. Solvent or ink goes deeper into the stick due to absorption. Let's dip another chalk stick for some more time in the ink solution. On breaking the chalk stick, it is found to be colored from inside. A distinction can be made between absorption and adsorption by taking an example of water vapor. For example, adsorption substance is concentrated at the surface. We observe that vapors are concentrated at the surface only and not throughout silica gel. In absorption, the substance is uniformly distributed throughout the bulk of the solid. We observe that vapor molecules are uniformly distributed throughout. text. If both adsorption and absorption can take place simultaneously, it is called sorption.